Okay, what we're doing here is we're looking at the Chapter 1 test review, and I'm going to go through all the odd problems. Okay, so let's get going on number 1. So number 1, first we have to look at it. It says find the value of x. So we look at those two angles we have, and we try and figure out what their relationship is, and therefore what exactly it is that we can kind of add, subtract, multiply, and figure out for x. So what we're going to do is we're going to look at this. So we see that that's a 90-degree angle right there. Okay? And we see that all three of those angles together make up a linear angle or a straight angle. Now the straight angle is 180 degrees. And so we're basically going to use a version of the angle addition postulate to say that all three of those add up to 180 degrees. So we know that if they add up to 180 degrees, we take away 90, and that leaves 90 degrees left. That means those other two angles have to add up to 90 degrees. So 59 plus x plus 2 has to equal 90 degrees. And once we have that set up, that's really kind of now we're done with the geometry portion, and we're heading on to the algebra portion of the problem. So we're just going to basically run this like any other algebra problem. We're going to combine like terms. 59 plus 2, 61 plus x equals 90. We're going to use the subtraction property of equality. Subtract 61 from both sides. And 61 minus 61 is 0. 0 plus x is x. 90 minus 61 equals 29. So we can stop there if we feel confident, or we can go plug 29 in there. That gives us 31. We go 31 plus 59 equals 90. Check. 90 plus 90 equals 180. So we know that x equals 29, and we're good to move on to the next problem. So as a general rule, keep in mind here that as you're going through this, you don't really need to watch from start to finish. If you got 1, 2, or 1, 3, 5, 7, 9, 11, and you had trouble with 13, just fast forward to 13. Watch 13, go back, start working on 15 on your own. So, moving on to number 3. Again, we have two angles here which form a linear pair. That means that they are 180 degrees. So we have 4x plus 6 plus 98 equals 180. Now, I'm going to accidentally put down 105 here. So I get 180. I'm going to subtract 105. I get 4x equals 70. I was going to put 75, and then I realized, hey, 75 isn't divisible by 4. Let me go back, check my work. And I realized that I should have put 104 down there, 104 there, and 104 there. Which means now that 4x equals 76, I'm going to divide both sides by 4, and I'm going to get x equals 16. Again, if I wanted to, you could go back and check. Plug that in and make sure. So, number 5 and 7, they are both angle addition postulate problems. Now, these are the ones we did where yellow and blue equals green. And I know that was really helpful for some of you and not so much for others. So I'm going to do 5 as yellow and blue make green, 7 as just a regular problem. With both of these, what I want to do is I want to first write my angle addition postulate sentence. Now what that means is there we have an inner angle plus another inner angle equal the larger angle. Okay? So this is just like the segment addition postulate, which is next, but we went over first. In that if we take that big angle, that big green angle, and we add and we cut it with HQ, that's this line right here, then what's going to happen is we're going to get two angles out of it. Now there's no way around it. Those two angles have to equal the first angle. So I'm going to keep it yellow and blue make green. So the measure of angle GHQ plus the measure of angle QHI is going to equal the measure of angle GHI. Now I've got my GHI, GHQ, and QHI above. So I'm just going to substitute x plus 27 plus x plus 57 equals 78. I'm going to combine like terms. X plus x is 2x. 27 plus 57 is 84. So now I have, that's my algebra problem. 2x plus 84 equals 78. Oops. So I'm going to subtract 84 from both sides. And I'm going to get 2x equals negative 6. Division property of equality lets me divide the same thing from both sides. And I get x equals negative 3. I'm looking for GHQ. Now I'm told the GHQ is equal to x plus 27 degrees. Or x plus 27 rather. So I'm going to rewrite that with x equals negative 3. Or the measure of GHQ equals negative 3 plus 27. 27 minus 3 is 24. So that's my answer. So, moving on to number 7. Now, I'm not going to do 7 yellow and blue makes green. I'm just going to note that the small angle plus the small angle here have to equal the larger angle. So that means that the measure of G, plus the measure of Gij is going to equal the measure of Hij. Hij is the large outside angle. Gij and Hig are both interior angles. So now again, we're just going to substitute in 2x plus 2x plus 55 for Hig, plus 2x plus 94 for Gij equals 149 for Hij. Now when I add this up, I get 4x equals 149 equals 149. Now I should be able to look at this and realize that something's going to be a little different on this one. I'm going to subtract 149 from both sides, and I get 4x equals 0. I then divide both sides by 4, so now I've isolated my variable, and I get x equals 0. Now, x equals 0 is a completely legitimate answer, okay? But I'm going to be honest with you, I always kind of freak out when I get x equals 0. So while I don't always check my work, I always check my work when I get 0 as my answer. So what I'm going to do is, well, first I need to find Hij, that's what the problem is. Hij is 2x plus, darn it, is 2x plus 55. X is 0. So that's going to be 2 times 0 plus 55. 0 plus 55. Or the measure of Hij equals 55 degrees. Now to check that, what I'd want to do is go back, plug a 0 into the other one. Right there, 2 times 0 is 0. So that makes that disappear. So then I have 94 plus 55. Now if I did this right, I should get 149. I do. 149 equals 149. That's a check. So I'm good to move on. So let's move on to number 9. Now number 9 and number 11 are segment addition postulate questions. Same general idea as the angle addition postulate, just easier because we're dealing with segments, not angles, and angles make things more difficult. So general idea of the segment addition postulate is that if you take a segment or a stick or the distance from here to Phoenix and you break it into small pieces, that all of those small pieces, when added together, are going to be equal to your original big piece. So, that means u to v plus v to w is going to equal u to w. So let's write that out. That's going to be my postulate statement. uv plus vw equals uw. Again, we're not putting any lines on top of it. We're not making it line or line segment or ray. We're just simply saying the distance, and that's what it means when we write those two letters next to each other. So by writing uv plus vw equals uw, what I'm actually saying is the distance from u to v plus the distance from v to w equals the distance from q to w. And this is called the angle addition postulate. Or sorry, the segment addition postulate. So now I know that uv is x plus minus 5. VW is 2x minus 6, and QW is 13. So I'm going to go 2x plus x is 3x. Negative 5 minus 6 is negative 11. And that's going to be equal to 13. So I'm then going to add 11 to both sides. And I'm going to get 3x equals 24. Divide by 3, and I get x equals 8. Now, we are not yet done. We are asked to find VW. So we know that VW is 2x minus 6. We know that x equals 8. So we're going to go 2 times 8 minus 6, or 16 minus 6, or 10. So we know that the whole length of the segment UW equals 13. We just figured out that VW equals 10, which means that in order for it to be 13, then UV has to be 3. Let's check that out. Let's plug in 8. We're going to go 8 minus 5. That is indeed 3. 3 plus 10 equals 13. That checks out. So what I'm going to do is I'm now just going to go to the page. Again, if this isn't making sense to you, go back, rewatch it. If it's still not making sense to you, drop me an email. We'll see what we can do before the test on Monday. So, QR plus RS equals QS. Okay, that's just my segment addition postulate. So I'm going to go 2x plus 25 plus 10 equals x plus 23. So first things first, let's combine like terms. So if I'm getting confused here, what helps is to write out the segments. I did that over on the left-hand side, what each one is equal to. And hopefully that will help. So we're then going to go 2x plus 35, that's combining like terms, equals x plus 23. Now we need to put our x's together. So we're going to subtract x from both sides. 2x minus x is x. Plus 35 equals 23. We're then going to subtract 35, and we're going to get x equals negative 12. Okay, so now what we're going to do, we were asked to find QR. QR is 2x plus 25. So we're going to go 2 times negative 12 plus 25, because what we're doing is we're taking that number that we just solved for, and we're plugging it back in. So we're now going to go 2 times negative 12. We're going to get negative 24 plus 25. So that's going to give us QR equals 1. Now if QR equals 1 plus 10, that equals 11. So we should be able to plug in negative 12 for x on Q to S and get negative 11. So let's check that out. Or positive 11. We can't have negative 11 because, well, the distance always has to be positive. So what we're going to ask is, does x plus 23 equal 11 if x equals negative 12? We go negative 12 plus 23. That's the same thing as 23 minus 12, which is in fact 11. Check and check. So we're done. We got it right. X equals negative 12. But more importantly, we found out that QR equals 1. That's our answer. QR equals 1. If you just put x equals negative 12, you're not going to get full credit. So to get full credit, go back in and substitute for x. The only time you don't need to substitute is like we did on questions 1 and 3, where it specifically says find for x. So 13, 14, 15, 16. We're going to do 13 and 14 because I kind of screwed up and forgot to do 13 and 15, but that's okay. So we're going to do these two. There are going to be 4 multiple choice questions like this on the test, 1 point each. So when we're looking at 13, we should be able to immediately get rid of 2 of the answers. Why? Because we haven't gone over them yet. None of you guys know what alternate interior or alternate exterior angles are. So don't sit there, and if you're not sure, go back, check your notes, read through angle pairs and how they work, what different angle pairs are, and what specifically properties they have. So if we go adjacent or a linear pair, well, let's start with a linear pair. Because a linear pair is both adjacent and that means next to each other. So adjacent just means two angles which are next to each other. They're actually two angles which share, remember we had that three-part checklist. Common vertex, one common side, no common interior points. So, but to be a linear pair, you need to be adjacent and supplementary. Now remember, supplementary means that the sum of the two angles is 180 degrees. So let's look at A and B. They are next to each other. Check. But do they add up to 180 degrees? Well, not that we know of. No. So it is just an adjacent. They're just a pair of adjacent angles. On number 14, again, we can get rid of corresponding because we haven't learned what corresponding angles are. Corresponding angles are formed when a transversal cuts a set of parallel lines. We don't know that yet, so that's clearly not going to be the answer. I know I can be a jerk sometimes, but not enough of a jerk to test you on something you haven't learned, at least on this test. So, moving forward, we then have vertical angles. Now remember, vertical angles are formed by opposite pairs of, or a pair of opposite rays. So, if we're looking up there, A and B right there would be vertical angles. You're going to get them mainly when two lines cross. So if we look back at number 13, just to show you, A and this angle would be considered vertical angles. Okay? So A and B are vertical angles. If we look up at the picture, they are clearly not vertical angles. We can get rid of those. They are not a linear pair. They don't add up to 180. And they're not vertical. So we're left with complementary, which means that it's got to be the right answer. But we can also look at the diagram and go, well, I know that complementary angles add up to 90 degrees. Here we have A and B splitting, or being created by the split in a 90-degree angle. Therefore, A and B are complementary angles. Okay, so the ones on the test, you're going to have to know the difference between supplementary, complementary, linear pair, adjacent, and vertical. Okay, so now we've got circumference and area, and this is the last thing we did, so it's something that people tend to struggle with. Other things we've been working on for a couple weeks, those you're going to have down a little bit more. It's always tough to take a test right after you learn something, but here we go. So, for these rectangles in 17 and 18, you need to find perimeter and area. So the perimeter of a rectangle is 2 base plus 2 height. The area is base times height. I'll go and change that back to an A in just a second. So I know that my base is 5 centimeters. My height is 11 centimeters. Which means that when I plug in, see there we go, to my 2 base plus 2 height, I'm going to get 2 times 5 centimeters plus 2 times 11 centimeters, and that's going to be equal to the perimeter. Again, the perimeter is the distance around the outside. 2 times 5 centimeters, 10 centimeters, plus 2 times 11 centimeters, 22 centimeters, equals P. So now we just add 10 centimeters plus 22 centimeters, and we get 32 centimeters. And that's going to be our perimeter. Now over on the right-hand side, we have area equals base times height. That means the area equals 5 centimeters times 11 centimeters, or 55 square centimeters. Again, we know it's a square centimeter for a couple reasons. First and foremost, because we are finding area. And area has to be in square units. Okay, so if we had gotten something other than square units, we'd probably be doing it wrong. Secondly, when we multiply 5 centimeters times 11 centimeters, we can multiply the 5 times the 11, and then we can multiply the centimeters by the centimeters. That's going to give us 55. So just like x times x equals x squared, so do centimeters times centimeters equals centimeters squared. So 5 times 11 is going to be 55. The centimeters squared are there. Okay, so Moving on, let's look at number 19. So number 19, we have a circle here. And I think I explained this in all the classes today, but you guys need to understand that pi, we use the term pi not to make your life more difficult, but in order to be precise. When you did geometry back in 7th or 8th grade, you used 3.14 to make your life easier. We're all big boys and girls now, so we're going to not worry as much about making our life easier and worry more about precision. If I write an answer in terms of pi, I am being precise. I am writing down the exact right answer. If I substitute in 3.14 instead of pi, I do not get as correct an answer. It's a pretty good approximation, and frankly, for most measurements and things like that, it's good enough. But I want you guys to work on being precise and giving me the best answer possible. In this case, that means including pi. Now, we're going to treat pi kind of like a variable. Okay, we can't add things to it, we can't subtract things from it, we can't multiply it by, or we can multiply and divide it, but just like we would a variable. So when we're looking at this, the circumference of a circle can be found one of two ways. 2 pi times the radius, or pi times the diameter. So in choosing which one of these to look at, I would just look at the picture. Here we see that we have 11 inches, and that's going to be our radius. So what we're going to do is we're going to go, and so the diameter, which is twice the radius, would end up being 22 inches. So here, since we're given the radius, we're going to use 2 times pi times 11 inches. Now let's look at this. 11 cannot be multiplied by pi. 2 cannot be multiplied by pi. But 2 and 11 can be multiplied by each other. So we're going to write our circumference as 22 pi inches. Okay? And even though you could sit there and put in 3.14, and I think you get 69.08. 69.08 is probably a very close answer, but 22 pi is exactly the right answer, and that's what we're going to use it. So the area is pi r squared. So r, again, equals 11 inches. So what we're going to do is we're going to go pi times 11 inches squared, or the area of the circle is 121 pi inches squared. Now if we were to look over at number 20, the diameter that they give us is 10. Now we can, as you can see here, we can easily find the circumference with the diameter. It'd just be 10 pi inches. But we then need to do an additional step to find the radius. And we do that by dividing it by 2. So we get the radius equals 5 inches. Okay, so last two, we're going to do 23 and 25. Now these are all multi-step equations, okay? And multi-part questions. So notice here, for number 23 and 24, I ask you to find the distance between the 2 points, the midpoint between the 2 points, or rather the midpoint between the 2 points, sorry for that typo, and then the second endpoint, and that's assuming that the first point is an endpoint and the second point is a midpoint. Now I know that last one really confuses a lot of people, so when we get there we're going to go really slowly. First one's pretty simple. Distance. We know the distance equals x2 minus x1 squared plus y2 minus y1 squared. We're going to label 3, 2 as x1, y1, and negative 8, negative 3 is x2, y2. And again, the hard part's done. We have our equation written down. We know where our points are. We just need to plug them in. So the distance, x2, negative 8, minus x1, 3, squared, plus y2, negative 3, minus y1, 2, squared. That's going to give me negative 8 minus 3 is negative 11 squared, plus negative 3 minus 2 is negative 5 squared. Negative 11 squared is 121, plus 25, negative 5 squared, which is 25. And again, that is going to be added together. So we get square root of 146. Now that's as much as I can do. I can't factor anything out. If I factored 2 out, I'd get 2 times 73. Those are both prime numbers, which means there's no ability to factor out that distance. So the next one, also pretty easy, is midpoint. Okay, now this is where we have an endpoint, that's x1, y1. We have another endpoint, that's x2, y2. And then we're looking for the midpoint in between the two. So the endpoints are x1, y1 and x2, y2. And the midpoint is xm, ym. And we use m because it's the midpoint. Okay, so down here, that's our equation, x, m, y, m. Those are our coordinates for the midpoint. And again, we need to do it twice. Why? Because we are on a coordinate plane, and so therefore everything we do for x, we do for y. We need to run all our calculations twice because we're dealing with both x and y. But now we have our equation now, which you guys should have too. So we have the equation. We have our points labeled as x1, y1, x2, y2. And we're going to go ahead and plug them in. So the x value of the midpoint is going to be x1 plus x2 over 2. We're going to plug in x1 is 3, x2 is negative 8, divided by 2. So we're going to get 3 minus 8, or negative 5 over 2. Repeat the process with the m's. y1 equals 2. y2 equals negative 3, and that is going to give us negative 1 over 2. So our midpoint is negative 5/2, negative 1/2. So I'm going to stop there before we go into the third part. Let's look at a graph just to help you visualize it. Again, it may be helpful to quick flip back and forth between these using the rewind, fast forward buttons. So that's 3, 2. That's negative 8, 3. So that point right there, negative 5/2, negative 1/2, is the midpoint. That makes sense. That right there is the square root of 146. And that's the distance. So those are the first two parts we have. So now what we're going to do is this third one. We're going to treat 3, 2 as the beginning point. We're going to call negative 8, negative 3 halfway. And we're looking for that other point. So now instead of labeling it x1, y1, x2, y2, I'm now going to label it x1, y1, xm, ym. Because again, we're dealing where we're given the first endpoint and the second point is a midpoint, and we are looking for the second endpoint. So we label 3, 2 as x1, y1. We label negative 8, negative 3 as xm, ym. Again, that stands for x of the midpoint, y of the midpoint. These are our equations right there. And those are derived from the midpoint formula. If you use the midpoint formula and you solve for x2 and y2, those are our second endpoints, this is what you would get. So now we can just sit there and go ahead. We can go x2. That's the x portion of the second endpoint. We're going to go 2 times negative 8 minus 3, or x2 equals 2. So 2 times negative 8 is negative 16. Negative 16 minus 3 gives us negative 19. y2, do the same. Again, we're on a coordinate plane here. Every point has an x value and a y value. So whenever we measure something, whenever we do something, we have to include both the x's and the y's. y2 equals the 2 times the y value of the midpoint. That's going to be ym, negative 3, minus y1, which is 2. That's going to give us negative 6 minus 2, or negative 8. Okay? Now let's really quickly, so that means that the other endpoint is going to be negative 19, negative 8. So I'm going to quick flip back here and look at where we found negative 19, 8. That's right where we thought it was. So what we can say is that negative 8, 3 is halfway from 3, 2 to negative 19, negative 8. Okay? Hopefully that helps. This is something that a lot of people have difficulty with, and we'll keep working on it throughout the year. So, finally, last one, number 25. Okay, so we got 3 separate problems here. We have sketching the polygon, the perimeter of the polygon, and the area of the polygon. Okay? So, what we're going to do is we're just going to put the points out there and make a pretty little pink house. Okay? Little pink houses for you and me. So the perimeter then, we look at our equations for perimeter, we don't have a perimeter equation for pretty little pink houses, okay? We have a perimeter equation for triangles, for rectangles, for squares, for circles, but not for pretty little pink houses. So what we need to do now is go back to our kind of general definition of perimeter, and that is the sum of the sides. So what we're going to do to get this perimeter is we're going to add up the value of all 5 sides. Now 3 of those are pretty straightforward. A to B, we can just count boxes, that's 8. B to E, count boxes, that's 6. And A to C, count boxes, that's 6. And so you could use the distance formula on those. You'd get the exact same answer. Counting the boxes when you have a perfectly horizontal or perfectly vertical line is just easier when determining distance. So we can plug those in, but that still leaves us E to D and D to C. So how are we going to do those? Well, now we are going to need to use the distance formula, because the distance formula is how we calculate length or distance on a coordinate plane. So again, we're going to quick jot it down. Distance equals x2 minus x1 squared plus y2 minus y1 squared. And I'm going to write out my points. E and D, that's 2, 3, and negative 2, 6. So I'm going to go x1, y1 is 2, 3. I'm going to give D the designation of negative 2, or x2, y2. So now when I plug in my distance formula, my x2 is negative 2. My x1 is 2. My y2 is 6. And my y1 is 3. So then we're going to go the square root of negative 2 minus 2 is negative 4 squared, plus 6 minus 3, that should be 3 squared, and that's going to give us 16 plus 9, the square root of 25, or 5. Okay, so the distance there equals 5. Now we can do the exact same thing for D to C. Now D to C, I'm going to make D x1, y1, and I'm going to make C x2, y2. And again, it doesn't matter which one you pick, just stick with it. Okay, I could have easily picked switch the points, one for the x1, y1, one for the x2, y2. I would have gotten the exact same answer. So that's going to give us y2, or x2, negative 6, minus x1, negative 2, squared, plus y2, 3, minus y1, 6, squared. So we get negative 6 plus 2 squared plus negative 3 squared. We get negative 4 squared. Negative 3 squared is positive 9. So we get 16 plus 9, square root of 25, or 5. So again, we get 5. And we can add up all the perimeters to make sure that they are, and we get 30. Yay! So we got the Pentagon, which is a 5-sided object, which this pink little house is. We just add up all the different little sides, and we get 30 as our answer. Again, if you don't understand it, go back, watch it again, watch it a couple times. Just watch this slide. I know the entire movie is a little bit lengthy, but each slide really isn't. Finally, area right there. Last one of the night. You guys can do this. So, we got our house. Pretty little pink house. We want to know the square footage inside. So let's write down all the sides. And again, we don't have an area for this. What we do have, though, is an area for triangles and rectangles. So we can say that the area of our pretty little pink house still resetting. Got it working. Leverage your hand, you want to go back on. Yep. Back to the bathroom. Okay, so sorry about that. Little bit of a glitch with the internet. So there may be a pause. So we know the sides are there. We don't have an area for pretty little pink houses, but we do know the area of a triangle, and we can find the area of a rectangle. So the area of the pretty little pink house is going to be equal to the area of the rectangle plus the area of the triangle. This is called the area addition postulate. Okay, if we break up a big object into little objects, add all the little objects together, we end up with the area of the big object. So the area of a rectangle is simply base times height. Here the base is going to be 8, the height is going to be 6. So we multiply 8 by 6, and we get the area of the rectangle as 48. Now that is 48. We don't know what units they are, but they're units squared. This could be inches, centimeters, miles, whatever. But we want to keep the units squared there to keep in mind that it is, in fact, an area issue. So, the area of the triangle. We know that the area of a triangle is base times height divided by 2, or 1/2 base times height. The base is going to be 8 still, and that's this right here. And the height, let's look at the height. We're going to go the height. Now, we know that here, y equals 3. And up here, y equals 6. So the height, that's from the base of the triangle to the top of the triangle. So the height there is going to be 3. So we're going to go base equals 8, height equals 3. The area of the triangle then is 1/2 of 8 times 3, or 8 times 3 over 2. It's 24 over 2, or 12. So the area of the pretty little pink house is going to be 48 plus 12 equals 60. Okay? So, if you have any questions, go ahead and email me. If any of this doesn't make sense, I apologize. Feel free to email me for more clarification, and I'll do what I can. Other than that, get some studying done. Have a great weekend, and I'll see you at the test on Monday.